So this is the experiment number 8 of the Maker's Lab, which is the same one as of the experiment 4 which you have done on the Vero board. Experiment 4, if to remind you about, it was about the yellow dot matrix in which you had to follow the circuit diagram and make it on the Vero board. So this time the same experiment we'll be going to do it on the PCB. So this is experiment number 8 of Maker's Lab, which we'll be doing on PCB, and the following points which I'll be telling you about, you have to cover them up. So first of all, you people have been given the footprint of yellow dot matrix, so you have to use the same exact footprint which we have been provided with. So the PCB size is to be small, is to be as small as possible, and to make it even smaller, there's a trick which I'm going to tell you about. You can use the space under the yellow dot matrix, and how to use it, because if you see, this is the same yellow dot matrix which you'll be using. Now see the trick. I am going to place some, just wait a second. I'm going to place the yellow dot matrix and going to tell you about a trick here. So this is the yellow dot matrix, just for the reference. I have placed it here. Now what you can do is that by going into the place in components, you have to select this miscellaneous connector library from the given libraries which you have been provided already with. In this miscellaneous connector library, there is a thing htr1x2, 1 multiplied by 2. This is basically called the multiply 1 row and 2 columns. So you have selected this and place it on one corner. Now just copy it from Control C and Control V, paste it, and by zooming it, you have to drag it. Just zoom it and be very precise. You have to drag and place it exactly under the holes of this yellow dot matrix. Now see one thing. Now see one thing very carefully. When I have placed this under the yellow dot matrix, you have been given the warning of contentions. So I have, just see, when I drag it out, there are no contentions or constraints, and I place it, everything is turned green. Don't worry about it. I'm going to tell you how to resolve it. This is just a trick. Again drag it. Yes. One by one, drag it. Zoom it in from from the control key and the mouse button, the center rolling wheel of the mouse, and place it exactly in the center of the center of the holes of this yellow dot matrix. Now select the other one. First Control C and then place it on one corner. Then you have to drag it. Then you have to drag it and zoom it in, and again place it in the center. Similarly for the rest other. Just see. And you have placed it. Once you are done with all the 8 of these legs of the yellow dot matrix, then select the yellow dot matrix and delete it. Now these are the pads for your yellow dot matrix, and you can easily place any component or anything under them. Just like, for example, if I am to take this transistor and place it under this yellow, not the transistor, oh I'm sorry, my fault, not the transistor. You cannot place the transistor under the yellow dot matrix. This is a fault which I was about to make. You can only put resistors under the yellow dot matrix. Only the resistors or the name or the headings can be placed under the yellow dot matrix, not the transistors or the ICs or the main headers. They cannot be placed under the yellow dot matrix. Now moving forward, why we are doing this and why to do all this hassle and everything, because the size of this PCB should not exceed above 100 mm by 100 mm, like 100 mm on this side and 100 mm on this side. It cannot be exceeded from this side, from these limits. So you have to follow this, and this is a very strict limit to be followed. To further reduce it, you can do furthermore things which I am going to tell you in the next few points, which will be covered. Now the footprint about the two transistors. You can see it from this diagram that we'll be using two transistors. You have used two types of transistors in the Verbo diagram, which was the two SS684 and 2N3904. Both have different physical sizes, a little bit difference in the sizes, but when you're doing in the Altium, both have the same footprint under the TO92 library. You have been given with the library. It's in the same region, components place in TO92. It's RS TO92. It's this. It's explicitly written here, transistor TO92. And there is only one component in it. Don't worry for this 2N3904. It is same for both of the transistors. So you can easily place it and proceed with it. There are no issues with it. Now moving forward, yes, regulator and the power supply section, which is the same as you have already done and you have been making it in the first 7 experiments. It is the same in this case. LM7805, the same voltage regulator with the two capacitors. One is 47 microfarad and the other is 4.7 microfarad with the 330 ohms resistor, and the new footprint of LED, the small footprint, the round footprint of LED, which is being also provided in the Altium libraries to you. Now, very important, just see, this is an old PCB of an old student. Fill areas are very important, and you have to add the fill areas because in this case the current will be a little bit higher. So without fill areas, your PCB, there is a high chance that your PCB won't be working properly or it shows some sort of issues. So there are certain ways or certain rules or certain constraints which you have to follow while adding fill area. First of all, you know how to add a fill area from this region by selecting the bottom layer and this fill option, and you can add the fill area of any size. Or very important thing, and if you have to rotate the fill area, you can just go here and rotate like 45 degrees there. Oh, I'm sorry, I added the wrong layer. It should be in the bottom there, 45 degrees, and see, it is rotated. So if you have to add any rotated fill area, you can add it like this and extend it in either way. Just rotate it in the 45 direction, and if I have to rotate it in this direction, I can do it like this. So you can do it. You can add the slanting fill areas as well. There is no issues, and you have to add. Now, very importantly, see, this is the ground path, the ground of the PCB, and how uniformly the fill area is added from all the way to the IC to this block connector. There are two basically the student has used two block connectors for the ground path. So see how uniformly the fill area has been added from all the regions. It won't be accepted that the fill area is thick in this region and then small here and then thick here. So non-uniformity in fill area, it should be avoided, and it is not liked. Like for example, see this, how uniform. It could have been better here. Like it could have been, you have to do it like this. It could have been better placed it like this. There is this yellow bubble, a little bit of bubble comes in, and you can just like uniform it furthermore, like this. Like now it looks more uniform and neat. And one more important thing, don't neglect it. This is the equivalent to it 03 IC, and it's the ninth pin of this IC. It's the ground pin, and see, ground pin is also connected with fill area. Like similarly, what I am trying to say is it could have been further improved here by zooming in and balancing out the fill area. It looks neat, otherwise your PCB will look ugly, and it has other sorts of issues which you will be dealing it in the later courses of your semester, like having different sorts of issues with the tracks and things. So fill areas from the regions such as from the from this connector, you have to use the new shape of the block connector which has been provided to you. This shape, you have to use this shape of the block connector. It is also, its library is also provided to you. This one, you have to use this shape of block connector, and it is compulsory to use this shape. And also the new shape of this heatsink LM7805, which is placed in library named Omar under the name of LM317. So you have to use that footprint which you have been using in the experiment number 6 and 7. It is the same one. You people are familiar with it, so I'm not going in the details of it. Now the fill areas, where the fill areas are required, it is very important. VCC ground is a must path. VCC what? The 5 volt VCC which is coming out from this voltage regulator to wherever it is going. Just see like this. This is the VCC path. This one, it is being regulated, and wherever it is going, it has been provided with a fill area. So fill areas are necessary, important, critical, whatever you think it is compulsory for this. With no fill areas, your PCB won't be getting approved, and it will create lot of troubles and hassle for you. Furthermore, from the ground path, from the ground block connector to the regulator, and also from the main and also to the main input of the regulator, it is a must to be there. Now a hint to be given to you how to reduce the size of the PCB and how to further improve or make your design neat. Are you seeing this section? What is done here is that all the resistors have been aligned close together so that a combined fill area is provided to them. If you're placing one resistor here, one resistor on some other end, one resistor there, so fill area will be scattered and you will be having all sorts of hassle to place the fill areas, and it won't look very neat. Fill areas, once again I'm repeating, have to be consistent, otherwise it will look bad. Like this, for example, this PCB has been selected to give you the example so that you don't repeat the mistakes. You have to zoom it in from the control key and the scroller of the mouse. Select this block, drag it here, and see this ring or this circle appears. It means that the two paths are connected, and it looks neat now. There are no sharp edges. Similarly, now here it looks ugly. You can reduce the size a little bit by connecting it again, and this circle appears. So see how neat it looks. Little bit, if I can increase the size, so it looks very neat. Now there's a hell lot of a difference in this region, and it looks very neat. No orthogonal tracks are to be seen like this. This is an orthogonal track. This should be avoided. It should not be seen in your PCBs. You can avoid it by doing it like this. This is a sharp bend, by the way, so also avoid it. It is not good. These type of tracks are also not good, so keep it like this. This is a more neat path of track, so avoid the orthogonal tracks in PCBs. Similarly, this bend, it can be seen, it is again bad, and this is a perfect slanting track. Not in the sense of being perfection, but it's wrong. See, all these things don't appear when you do manual routing. That's when manual routing is preferred in the circuit. Moreover, another way of reducing the size is by you can place your name and details under the yellow dot matrix. But the trick which has been told to you of placing these miscellaneous connector blocks instead of the footprint of yellow dot matrix, first be strict on this thing, that first you have to place on the yellow dot matrix, then you have to place these miscellaneous connectors and on the exact hole size. Your requests won't be entertained in the later thing that I have placed the pads as like under the yellow dot matrix or anything, and now it is not being fitted. It has been practically checked that this can be done, and many students have been doing it in the previous sessions and things just to reduce the size. It will be encouraged and highly encouraged if you use the footprint of yellow dot matrix and still your size is less than 100 mm by 100 mm on both sides. It will be encouraged, highly encouraged to do that. But for those students who cannot find any other way to reduce their size, this is a trick that place the connectors under this and then remove the block footprint of this yellow dot matrix. Furthermore, you have to add the strings which includes the name, roll number, group number, which is a compulsory thing to add, and all of them should be in the bottom layer. Remember, only 2 layers are to be used in this PCB. Only 2 layers. Strictly listen to this. Only 2 layers. First, the keep out layer, and your boundary will be in the keep out layer. This is the keep out layer, and the boundary of the PCB should be in the keep out layer, and you have to select it from this. This is the keep out layer. It will come ahead. This is the keep out layer. You have to select this and place the boundary from this line section and select the keep out layer. Now the other layer is the bottom layer, and everything else should be in the bottom layer from the text of your name, group number and roll number, and all the other things should be in the bottom layer from the standard dimensions. And don't miss these standard dimensions. These are also compulsory to add from on the other side of the PCBs. One more thing, this is not a proper fill area. If you think that this is a proper fill area, you are adding a fill area. Just suppose on this track, if you're adding a fill area and this is a fill area. If you're thinking that this is a fill area, no, then this is not a proper fill area. Let me show it to you what most students do. This is barely of any width and this is barely of any use. You have to increase the width of this fill area to a substantial. Now don't keep the width like this. This looks ugly definitely, but keep the width to a substantial size. Like this is a reasonable width. This is a reasonable width or thickness. So, and not like this, what I was trying to say. Once you have placed the fill area, now the second thing, connecting it from here, and look, it looks non-uniform. In one region it is more thick and in the other region it's less thick. So it should be exactly same in the entire region. Try to keep it exactly same. Zoom it in, drag it here, connect the 2 circles, and it should be exactly same. Look, see, in this way it looks neat. And I have already told you how to slant the fill area so that you can cover these content tracks as well in the fill areas. Not because of this is just a demo thing of the VCC ground and the main 5-volt path of the circuit. So now to end this thing up, there will be only one revision in this experiment. One is the normal initial submission, which you people are already doing, and the other is the only revision 1 submission, which will only be done once, and there will be no rev 2s, revision 2s or revision 3s. So this you will be only given one other chance to get your PCBs approved. So do a lot of hard work and get it approved.